Okay, so let's talk a little bit about the beginning of chapter 3. We'll do a little bit on argument forms and introduce the logical operators, and talk a little bit about formalization and give a lot of examples of how to formalize in propositional logic. All right, so when we think of the word formal, a lot of times we think that just means technical or abstract, but really in logic, when we say formal, we're talking about form. So form as in a sense, the shape of the reasoning we're engaging in. So yeah, in a certain sense, reasoning has shapes, but we call them forms or patterns sometimes. And of course, we're specifically interested in valid argument forms, deductively valid argument forms, which is what we defined in the first lecture. So we actually give names to simple valid argument forms, and ultimately, the reason we do this is because these simple valid argument forms are turned out to be part of our proof procedure. So, for example, this English argument, if Cassandra is smiling, she's angry. Cassandra is not angry. Therefore, Cassandra is not smiling. It has a certain form. We call it modus tollens. That's an old Latin term. And this is the form it has. This says, if S, then A, not A, therefore not S. And we use modus tollens as a rule in our proofs. By the way, this little, I won't be using it much, but it occurs in the book, and this is just one of the common ways of writing therefore in a symbol. So we're now going to start learning the formal language of propositional logic. And we're going to approach it casually at first, and then later we'll define it rigorously. So first, as we've already mentioned, we use capital letters to stand for entire, simple, or atomic propositions. Now, formally, we tend to restrict the capital letters to P, Q, R, and S, and T, but when we're operating informally, sometimes we just use whatever capital letter seems to fit, especially when we're doing translations of English statements. So, for example, the proposition Serena is awesome might be represented by the capital letter S. Or A, just whatever seems to make sense to you. So all natural languages, like English, contain words that connect simple propositions together. Sometimes we just call them connectives, but the more general term is operator or logical operator. So English has tons and tons of operators, it turns out, but we only use a few of them, 5 to be specific, and they are these. So there's not, which we call negation, and we use this little tilde symbol, this is called a tilde. And there's and, which is called conjunction, and we use this thing called an ampersand, although when I'm actually writing in freehand in class and here, I'll often write it just like that because it's easier for me, and you can do that too. There's or, which in logic we call a disjunction rather than a conjunction, and that's represented as a wedge or a V. There's if, then, which we call the conditional, which we represent with this arrow going from left to right. And there's also if and only if, which I said before, sometimes we abbreviate as IFF, but we symbolize, we call it the biconditional, and we symbolize it as this double arrow. All right? So the other thing we use is parentheses, or sometimes we call them brackets, that allow us to be clear about what a proposition that employs multiple operators means. So if you look at that, we don't know what that means, right? It could mean this, if P then Q and R, or it could mean if P then Q and R. So we use parentheses or brackets to disambiguate complicated sentences or propositions like this. So later we'll learn that to be a well-formed compound proposition in propositional logic, you need to have brackets on the outside. So if P then Q without brackets is actually not a well-formed sentence. It has to have brackets on the outside. This, if P then Q and R, is not well-formed even though there's brackets here and here, because you need brackets on the outside of that as well too. It's not the case that P or R could be written like this with brackets on the inside of the negation or totally on the outside. These two mean completely different things actually. This says it's not the case that P or R, and this says it's not the case that P or R. And this is actually not well formed. You don't put brackets around. You don't ever put brackets around an atomic proposition. So this is correct, and it doesn't require. It also does not require parentheses on the outside as well. Now, there's actually rules that make this very explicit. So I'm just telling you this intuitively. It turns out that there's a mistake in some of the exercises in Chapter 3. I'll try to remember to mention this later, where they accidentally put brackets around atomic propositions with a negation on the outside. Okay, so let's work now on formalizing some English sentences in propositional logic. So to do this, so that we're all on the same page, we'll just go ahead and create a little interpretation. So P equals or means it is pie, C means it is cake, M means it is moist, F means it is flaky, and S means it is sweet. Okay, so P, C, M, F, and S. Remember, we're using capital letters. You have to use capital letters. If you use small letters, then it's wrong. So either it is pie or it is cake. Now, when you're listening to this video or watching it, what you should do is stop and try it, and before I do, and then see if you get it right. So use the pause button a lot in the next 5 or 10 minutes here. Okay, so either it is pie or it is cake. Well, pie is P, right? Yeah, damn it. Pie is P, and cake is C, right? So either it is pie or it is cake, pie or cake, and then we put parentheses on the outside, right? So either it is pie or it is cake. If it is pie, it is not cake. Try that one. So pie, cake, not cake. Let me erase that. Myself a little space here. So we have not cake, not cake. If it is pie, it is not cake. Now I didn't put the then in there, but you were just going to assume the then. So if it is pie, then it is not cake, and brackets around the outside. If it is pie, then it is not cake. If it is pie, then it is flaky and sweet. All right? So if it is pie, then it is flaky and sweet. Right? And then, so we put brackets around this, but the whole formula actually needs brackets around it too. If it is pie, then it is flaky and sweet. Okay? If it is cake or pie, then it is flaky or sweet. So try it. Turn me off and turn me back on. If it is cake or pie, it is cake or pie, then it is flaky or sweet. Okay, brackets here, and then the whole formula needs brackets around it too. If it is cake, if and only if it is sweet but not flaky. It is cake, if and only if it is sweet but not flaky. Now, but, interestingly, in logic, just means and. So, it is cake if and only if it is sweet and not flaky. Parentheses and parentheses. It is cake if and only if it is sweet but not flaky. It is flaky pie or it is sweet cake. Now, here what we've done is we've contracted, right? Our expression, it is flaky pie, basically means it is flaky and it is pie. And it is sweet cake means it is sweet and it is cake, right? So it is flaky pie, it is flaky and it is pie, or it is sweet and it is cake, right? So it is flaky and pie, or it is sweet and cake, and brackets around that. It is flaky pie if and only if it is not cake or it is not moist and sweet. Okay, so it is flaky pie. It is flaky pie. It is flaky and pie. Come on. It is flaky and pie. Sorry, I keep hitting the wrong button here. It is flaky and pie. If and only if and only if it is flaky and pie, it is flaky pie if and only if it is not cake, or it is not moist and sweet. It is not the case that it is moist and sweet. Okay? So it is flaky pie if and only if it is not cake or it is not moist and sweet. Now we're missing some brackets right here. We have brackets here, right? So this is what we would call a formula. This is what we would call a formula. And this entire disjunction now requires brackets. And then the whole thing requires brackets. Okay? Notice you're always going to have an even number of brackets. So if you ever count and you get an odd number, you know you've done something wrong, right? So it is flaky pie if and only if all this. It is not cake or it is not moist and sweet. It is not, notice this says it is not the case that it is moist and sweet. Oh, whoops. There's a mistake, right? This is wrong. This should say and, right? Because this says and. It's flaky and pie if and only if it is not the case, it is not cake or it is not moist and sweet. Yeah. So if it is moist, then if it is cake, then it is sweet. If it is moist, then if it is cake, then it is sweet. Right? If it is moist, then if it is cake, then it is sweet. Little trick here. These nested, we call these nested conditionals. It is moist and flaky and sweet. Moist, oops, down here. Moist and flaky and sweet. Now, where do you put the parentheses? Well, interestingly, is if you have a string of ands, we'll learn this later too, a string of ands or a string of ors, doesn't really matter. It doesn't change the meaning. So you can, it's kind of like having a string of pluses or a string of minuses in math, right? So that's fine. And the alternative is fine as well, which I'll just write down here, right? So you can group these any way you like and you'll preserve the meaning. It is neither moist nor flaky. It is neither moist nor flaky. Now, neither nor in English means that neither one of them, right? So it's not moist and it is also not flaky. Right? Okay, so if you're just watching me do this, remember you're not learning anything. You have to be turning me on and off and trying each of these on your own. If you're just watching, you're not learning. Guarantee it. It's really easy when somebody else does this. It's neither moist nor flaky. Now, interestingly, as we'll learn and be able to prove later, another way of writing this is it's not the case that it is moist or flaky. It is neither moist nor flaky means it is not the case that it is moist or flaky. You should also try to copy the way I'm talking right now because it's the way logicians talk when they're being very explicit. So I'm saying it is not the case that it is moist or flaky, that is a very precise way of making this statement, because if you just say it's not moist or flaky, we don't really know exactly what you're saying. All right. If it is moist and flaky, then it is neither pie nor cake. It is pie or it is cake. Thus, it is either not moist or not flaky. Well, that's an argument, right? So let's represent it as an argument. If it is moist and flaky, so premise 1, if it is moist and flaky, if it is moist and flaky, then it is neither pie nor cake. Then it is not pie and it is not cake. Right? If it is moist and flaky, then it is neither pie nor cake. 2, it is pie or it is cake. It is pie or it is cake. 3, thus, if you want to write that, thus it is either not moist or not flaky. So it is either not moist or it is not flaky. All right. So again, I mean, I sound like a broken record here. If you just watched me do it, you were kind of nodding, saying, oh yeah, I get that, I get that. If you didn't do it yourself, you didn't get it. That's all there is to it, okay? All right, here's just some quick study questions. Again, you're going to need to pause here, and this will all just be silent, just for a very quick review, and then I'm posting a worksheet associated with this, which is what you're going to want to produce for class. I'll break my silence a little bit here on this one. You might have actually written this, and that would have made sense too. If Sarah is quiet, then she is patient. If and only if she is reticent. What that actually shows is that this comma is telling you quite a bit, right? That's how we use commas in English. So the comma actually tells you in English where the parentheses go. Okay, that's it.